Hello friends, my name is Meenal Radhakrishna Tikam. In this video, we are going to discuss about open channel flow. This topic is there in Civil Engineering's third year in the subject called Applied Hydraulics 2. The module number is 3. It is a very important topic even in exam point of view because it contains almost 50% of our syllabus. The main objectives to learn these topics are as follows. The very first one is definition of open channel. Meaning of open channel. The second one is classification of open channel, which will be based on two parts. The first part will be according to section, and the second part will be according to flow. The third part of this topic will be the analysis of uniform flow, in which the very important topic called as economical channel sections will be analyzing. And the last and again another important point is non-uniform flow. Now, before the commencement of this particular topic, let us first understand what is the meaning of open channel. Now, whenever I say open channel, the first thing that will come to anybody's mind is that it will be the channel in which water is flowing, but it will be not covered. It will not be covered at top. As a layman, this definition is more than sufficient, but for engineering students, this certainly is not a definition. Okay, so as an engineer, you must understand that it is not just whether it is covered on the top or not that matters, but whether it is flowing under atmospheric pressure or not, that matters the most. Further, to elaborate this particular concept, let us take two examples. The very first one would be the river, which is flowing, and another would be a circular sewer in which water is flowing at depth D. Now, when we put forward these two examples, the very obvious one is that river would be taken as open channel flow without any hesitation or doubt. But that's not the case with sewer, because many of us would think that since it is covered at the top, it won't be open channel flow, but it will be a closed flow. But like I have discussed earlier, that it doesn't matter whether it is covered at the top or not. What matters is whether it is under atmospheric pressure or not. And as we all can see here, this particular region has no water, which certainly indicates that this flow is under atmospheric pressure. So that leads us to our final definition, which states that an open channel flow is a flow which is running at atmospheric pressure. Now further again analyze these two examples. One is of river and other is of sewer. As you can see, river has no particular defined dimension. Here there is no defined dimension. So the river is usually called as non-prismatic channel. Whereas as you can see, in case of sewer, I will certainly have a diameter, I will certainly have a periphery, which tells me that it does have a specific dimension. So this particular flow is called as prismatic flow, or the channel is called as prismatic channel. Now, why there is a necessity to understand non-prismatic channels and prismatic channels? Because in our syllabus, we are not going to study about river flow, but we are going to study about prismatic channels. Means the channels who would have a definite sections, such as circular channels or trapezoidal channels or rectangular channels or even a triangular ones. So in open channel flow, finally I can conclude that we are going to study about the flow which is open to the atmospheric pressure and have a definite dimension or a specific dimension. Thank you.